Hello again. I'm here today to talk a little bit about data input and output in a shell script. And so to make that conversation a little bit more real, let's do it with some examples. First, let's discuss the fact that there are three basic methods by which you can get data into your shell script. One is through prompting the user. The second is by supplying the data on the command line as a parameter. And the third way would be to read it from a flat file, maybe a delimited file, something like, say, the password file that we're somewhat familiar with. Or it could have been a file that you created in a previous script. So let's explore an example. Say we wanted to create a file. So we can do that with VI. And I'll name that file addname.sh because it is a shell script. We know that all shell scripts start with the shebang and bin bash. And I don't know, just to make it clean, we'll clear the screen at the very beginning of the script. Now, we need to prompt the user for some input. So we can use the echo command for that. And add a new data entry. And that should do it. That we just want to sort of start our user off with a little prompt there. And then we're going to actually echo the first prompt. We'll call that first name. I'll put a little space after the colon there so that when the prompt actually appears on the screen, that the data that the user enters will not be butted right up against the prompt that they see. Now, you notice that I used echo with the -n along with it. Go ahead and use the man page on echo so that you understand what that means. It should become pretty clear once you look at the man page. And then I'm just going to use a shell script command, read. So read is one of the first ways that you can use to get data into your script via a prompt. And we'll just use another echo after that with last name, just to show you the pattern. And you could do that over and over and over again. And finally, you got all your data that you'd like to have collected up. You can then just echo that data by now. Remember, when you first refer to a variable, you just use its name, like we did in this case. But if we want to look at the value in that variable, we can come down and use the $sign in front of it. And say we want to delimit that file with colons. We could do that. And then add that file to, we'll call it name list. Okay. Now you can see that I made a typo error down here. I didn't spell first correctly. So let me position my cursor in the correct spot. I'll hit the A in the VI editor to open insert mode after the cursor, and then type in the correct letter that I want to add. I'll hit now escape to go back to command mode, and well, I look like I'm done with my little script. So what I can do is use the colon WQ to write and quit. Okay. What's the next thing I need to do? Let's look at all of my shell scripts. And this one that I just made does not yet have the execute permissions on it. So that's the next thing I need to do, is add execute permissions to that script. And now it should be ready to run. So I can be sure to run the script in my current directory by using the // and then the name of the script. I can tab to fill in the rest of the name, as long as that part that I had entered already is unique within this folder or directory. And let's see what happens. Well, the first command was clear, so the screen got cleared. I have my add a new data entry. Okay, first name. So I'll just say Gregory and Smith. Okay, now I'm back at the command prompt. So what was the last? Let's look at the last few lines in that shell script. I wanted to echo to a file named namelist. So I should now have a file named namelist. Oops. I do. It wasn't in existence at the beginning of this script, so it got created by the script. The double arrow meant if the file didn't exist, create the file and put this data in it. If the file already does exist, then append the data to this file. Let's see what's there. The data that we entered when we ran the script. So let's go back and run the script one more time. And we'll now put in another name. That's fine. But now let's cat namelist a second time. And we see that the previous data was not obliterated. It still remains. And the new data has been added to the list. So this basic process, this basic technique could be used to create really let's just go back. There we go. So this basic technique that we see on the screen can basically be expanded upon to create any kind of data that we wanted to save. Okay, we could do data entry, in other words, and then create any kind of delimited file that could be used for a future project. So I hope that is helpful to you. And a second way we could add data to a script is by providing it on the command line. Let's take that same script that we had been working on, so add name.shell, and we'll just modify it a bit to, instead of prompting for the user like we were doing here, I'm going to get rid of all those lines. And then show you a few things about command line data access. So one of the first things to know about data on the command line is that that data is stored in some specially named variables that Linux understands. And they are named $1, $2, $3, $4, etc., etc. The name of the script itself is stored in $0. So I still have a first name that I would like to keep track of. And if I pass that in as the first parameter to my script, I could just represent it in this fashion. And the last name could be the second parameter to my script, which I could represent in the same fashion. Of course, let's spell it correctly. Okay. And instead of saying add a new data entry, we can just merely say a new data entry has been added. And, well, in fact, for the most simplistic of purposes, that should do the trick. Now, in this particular type of script where things are provided via the command line, of course, the user needs to understand that that is how the script works and provide the proper parameters. Now, what happens if the user doesn't do that? Well, you're going to have some problems. So there are some ways to try to make things a little bit more robust, let's say, less error prone. So one of those things that we can do is add an if statement and reference another special variable that is understood by the script, $#, $hash mark. That represents the number of parameters that existed on the command line. And if that number turns out to be 0, meaning when the user ran the script, they added no parameters at all, then we could kindly echo out that this script requires 2 parameters. Okay. And then actually perhaps echo another line out that says usage. And it's add name dot and then a first name, and then the last name. And then, of course, at that point in time, we can exit the script by force, and we could even exit with a number. We'll talk about exit codes perhaps in another video, but when any script exits, you as the designer of that script can decide to provide a specific numeral code at time of exit that other calling programs can reference so that they understand why the script failed. So in this case, we're just going to make up the number 5, and we'll designate that special meaning as, misuse of the script. So let us let's give it a go and see what happens. All right, so we already had that script named. We already had given it execute permissions. So, oops, we didn't add any parameters, so therefore we got our little error message. This script requires 2 parameters and a little message about the usage. So while we're at it here, I'll talk about this special variable, $?. $?, as you can see right now, has the value 5. Well, guess what $? Is? It contains the return code of the most recently issued exit status. So in our program, we had exit space 5. Well, when our program ended early because we did not provide a first name and a last name as the parameters, then the program exited with that return code of 5. So let's try to run the program correctly this time with Joanne and Wilson. So we've got a issue at line 11, command not found. Well, this is a great way to discuss troubleshooting. So we got a line 11 and 12. We have a problem. So let's count down. Line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Well, I misrepresented the variable names with those $signs in front of them. You only use the $sign with a variable when you want to extract the value. This time I'm assigning, so I don't need that representation. Let's fix that, write and quit, and give it a go a second time. This time a new data entry has been added, and the file to which it has been added is the one that we put at the end, name list. So let's go ahead and look at that last line in name list. And, ooh, there's nothing there. So, we're going to have to do a little bit more debugging. What happened? Let's look at add name.sh. And, oh, look at me. I used two different names for the variables. I used fname and lname up here, and I used first n and last n down here. So, you know, Ms. McCusker, make up your mind. What do you want to use for the variable names? Let's change it to first n and last n so that they match. Okay. Now, let's write that. Make sure you hit escape to get back to command mode. Write and quit. And now, give it a go one more time. A new data entry has been added. And now it is correct. So took a little, multiple tries. You never get the script right. Well, not you never. You rarely get the script right perfectly the very first time you write it. There's always a little bit of debugging, walkthroughs that need to be made with experimental data, and then you get things correct. And now it's time to discuss the third way that you can get data into a script, and that is to read it from a file. And I happen to have a file on my computer here named employees, and you can see that it has a lot more data than our name list file. But in fact, the first two entries, not three, but two, have a first and last name in them. So this file possibly could be used as a source of input to my little program that I am writing to add names. So now, instead of prompting the user or putting things on the command line, we're now going to extract our data from another file on the computer. So this sometimes is called a batch process, where the program can run or get executed, perhaps even called by another script, and no user intervention is really required at all. So how are we going to make that happen? Well, this can be done in a variety of ways, but here is just one. We're going to define a special variable, IFS, and you see that it's in all caps, which is a common way to designate either environment variables or just variables with special meanings within the Linux environment. This stands for input field separator. So we're going to set that equal to the colon, because that is the delimiter that we saw separating the values in our input file. And then I can just cat employees, which is the name of my file that I created. And I'm going to pipe that data into a while statement. So while I'm reading first name, let's see, and these variables, you name them, and the names that they have will, somewhat represent the data that you are reading. So we'll go back and look at that employees file again and convince ourselves that the data that was separated by those colons represented a first name, a last name, a title, a room number, a phone number, and the department for that individual. But that's what that represents. And then we're going to remember the do statement or the while statement is enveloped by a do and a done, and everything inside of that do and done is cycled through over and over again until we run out of data. So now I'm going to hit the I for insert, and so I'll need to change my program around just a little bit, and I will not need those anymore, and that may or may not be necessary. I want to take this line that I had. I'm in command mode. I'm going to hit YY on my keyboard. That's a yank. Puts it into the computer's memory. And when I hit now P, it takes it out of sort of like the Windows clipboard, puts it back into my editor. I really don't need this line down here, so I'll delete it. And now I have really everything done, and a new data entry has been added. Very good. And now every name from the employees file will be added to the name list. So not just one, but really all of them in this case. So we don't say A, but new data entries have been added. Okay. So here we have our file that we are ready to call a rack to for adding our data from the employees file and only extracting the first and last name portions and adding it to our name list. So using the third data availability method, which is reading from a file. So let us run this file and we'll see what happens. First, let's look at employees and name list. So here's our employees file. You can see how it's formatted, and it does indeed have a first name, last name, title, a room number, telephone, and department. And Now we're going to look at our name list file that we had created, has a series of names in it, and now we will run add name. New data entry items have been added. Well, let's take a look at name list now, and yep, there are those new names. So now you know 3 basic methods to get data into a script. Prompting the user, supplying it on the command line, and reading from a file. We'll work on more soon.